3.6, last section in chapter 3, kind of a culmination of the things that we've been doing. We're going to see some pieces that are transferring language into symbols. We're going to see some pieces of analyzing arguments, kind of like we were doing with Euler diagrams. We were deciding if arguments were valid or invalid. But instead of doing them from an Euler diagram, we're going to be doing them from a truth table. So the first 3 problems that we have today are going to take the majority of our time because they're really big truth tables. So before we do that, some steps about how we go about analyzing such an argument. So a lot of writing here on the first slide. So when we're testing the validity of an argument with a truth table, the first thing we have to do is we have to turn the argument into symbols. Okay? So we assign letters to represent each component of the statement in the argument. That's the first step. The second step is to express each premise and conclusion symbolically. So that means to create all of the if-then statements or the and statements or the or statements in symbol form. Step 3 is to form the symbolic statement of the entire argument by writing the conjunction, right, the and statement of all the premises, as the antecedent of a conditional statement, and the conclusion as the consequent. And then step 4 is actually creating a truth table for everything that we created in step 3, and then analyzing it. If it's a tautology, it's a valid argument. And if it's not a tautology, then it's invalid. Okay, so we're going to do 3 examples of this type of a process, but they're going to start sort of at varying steps along the way. The third example is going to go through all 4 of these steps, okay? But the first couple of examples are actually going to start sort of midway through the process. So problem number 1, we're going to use truth tables to determine if the argument's valid or invalid, is already in symbolic form. This has step 1 done, okay, and step 2. They've actually assigned letters. We don't have statements corresponding to them, but presumably there would be. And they've created the argument in the same structure that we saw our sort of our arguments written that were all written out in sentence form last time with the Euler diagrams, right? Statement 1, statement 2, there's the therefore line, and then there's the conclusion, okay? So we're actually at the point where we're looking at step 3 on this problem. You guys ready? So step 3 says that we're going to form a statement of the entire argument by writing the conjunction of the premises and as the antecedent of a conditional statement and the conclusion as the consequent. So what they're saying we're going to do is we're going to take each of these statements and we're going to put an and between them. Okay, so that's the first thing we're going to do. So one statement is tilde P implies Q, and then we're going to do an and the second statement is very simply just P. Because that's creating a conjunction of the premises. It says it's going to be the antecedent. That means it's another if-then statement. So all of this is the if part of another statement that has the result, the therefore part, as the conclusion. In this case, the tilde Q. Okay? So once we have our symbols created, which they've already done that for us, and we've put our argument structure in place, we join all the pieces that are above the line with an and statement. We put them in a bracket, and we make that the if part of a conditional with the conclusion, the part underneath the line, as the consequence or the conclusion. Okay? What we want to do then, this is step 3. That we're done with step 3. Step 4 is to actually create the truth table for this. And as you can see, there's a lot of pieces. Okay? These truth tables are going to get very lengthy, and you might remember that there was a lesson a while back, I think it might have been 3.2 or 3.3, where I kept changing the names of column headers to like 1 and 2. Remember that? Yeah, we were leading up to this, because if I don't put them on there, I will run out of space on the screen here for sure. This is my notes. They match yours. And you can see I've already run out of the space on the tops of all of mine too, and they're actually all written out. So those are just going to give us a condensed way of doing our column headers. So there are only 2 statements here, P and Q. So we'll start out our truth table with columns for P and Q. So I have a column for P, a column for Q, and somebody tell me, what will column P's, T's, and F's look like? Try for me, Amani.
Is it true, true, false, false?
It is. Good. True, true, false, false. So somebody else give me column Q.
True, false, true, false.
Yeah. Thanks, Molly. True, false. True, false. Okay. They always start out like that. This is for two statements, P and Q. Okay, we'll have other ones that have more than two statements, but this one's just P and Q. And then what we're going to do is we're going to do this like we do algebra, right? We start at the innermost parenthesis on the left-hand side. And inside that parenthesis, we notice we do have a negation, right? So I need a column header representing that particular negation. So we don't do column headers for all negations, just the ones we need as we need them. So tilde P would be right here. I do know that there's a tilde Q on the other side, but I don't need it yet, so I'm just going to wait to do it later. Okay, if you really wanted to do it now, you could, but there's no need for it yet. We can fill in all the T's and F's, but I actually want to do all my column headers first. Make sure that I get all those in place, and then I can go back and I can look at all the true, false, and how they should structure. Okay, so looking at the inside of the parentheses, I now have a tilde P and I have a column for Q. So now I'll have a column header for tilde P implies Q. That is the first parenthesis, right? Innermost piece. And I'm going to call it column 1. So everything right here is 1. Then I'm going to join that, sort of moving outside of the parenthesis now, with the P statement. So this will be 1 and P, because I have an and symbol between them. As my next column. Okay? We'll call that column 2. So all of this now is 2. Okay, so we've done everything on the left-hand side now, yeah? Column header-wise anyway. On the right-hand side, I have a tilde that I haven't included yet, so we'll do that now. That will be the tilde Q. If you want to give it a name for, another name like I did before, that's fine. I usually do column header names when I have compound statements, not usually with negations or simple statements as they are, because it doesn't really help me a lot. But this last one then is the last individual piece. Like I've got all the little pieces up. So what I need at this point is I need to do 2, that is column 2, which was the entire left-hand side, implies tilde Q. And that will be the end of the column headers. There's generally lots of columns with these. Okay, any questions on the column heads in any locations? Okay, so I know it's been like a week since we've done any truth tables together, so we'll take it a little bit slow. Tilde P, how do I find the tilde P column? You look at P and you do the opposite. Yeah, the negation, which is the opposite. Yeah, so tilde P will be reverse of P, so it'll be false, false, true, true. Good. The tilde P implies Q. So implications are the tricky ones, I think. So tilde P is this column, and Q is this column. And unfortunately, our first exposure today, we're going backwards on the table, which is not the most intuitive way of doing this, but we'll be okay. Now, I remind you, when we have an implication, a conditional, right, like one of these, there's 2 ways that we get true statements. The first one is true implies true. And we get a true statement for true implies true, true and true, true or true. So anytime we have 2 trues, we always get a true statement. But implications are also true when the premise is false. And I don't really want to go back through all of the reasons of why that worked, because we already did that, even if it's been like a week and a half. So that was back in section 3.3, if you need a reminder for that later. But anytime a conditional starts out false, which is what happens on the first two rows here. This first one says false implies true when I go backwards. The second one is false implies false. Anytime a conditional starts out false, you have a true statement. So these first two are true. Again, the third one, I already mentioned this before, is the true implies true. That's always true, whether you've got ands, ors, or if-thens. The last one is the only time a conditional is false. It's true implies false. That's a false statement. Okay, so anytime you have true implies false, we get a false statement. Okay. Next, we're going to do the and statement column. So this one says I have column 1, when I've labeled that way, and column P. When is an and statement true? When both are true. So I have to have both true in order to have an and statement true, and if I have any falses at all, it's false. So I'm highlighting the columns that we're considering as we go so that we can make sure and keep it straight, especially from a distance because you guys are further away. So on the first row, I have true, true, so it's true. On the second row, I have true, true, so it's true. On the third row and the fourth row, column P is false, right? And statements need both statements to be true. P is not true. So those two are automatically, false. We have a tilde column again. Okay, so negation columns are the ones that are really nice and quick. So we have the negation of column Q. So Q was true, false, true, false. So what's the negation of Q? False, true, false, true. Excellent. And then we're going to do column 2 implies column tilde Q. So it's going to look like this. Okay, implication again, right? So true trues are true, and false implies anything is true. The first one is actually true implies false. That's the one time when it's false, right? Anytime you have a true implies false, a conditional is false. The next one is true implies true, so it's true. And then the third one and the fourth one both start out false, which means the conclusion is true. Okay, so we're almost done with step 4 from our list of 4 steps that we wrote out. Step 4 says I create the truth table, which I did. And then I look to see if the last column is all truths. If it is, we call that a tautology. Is this a tautology? No. So if it is a tautology, we have a valid argument. If it is not a tautology, like this, we would then have an invalid argument. So this is invalid.
So if the last column was all true, it would be valid?
Yes, exactly. And we'll see some before we're done today. Okay, you ready for another one? Okay, so in some sense, you might say, well, this one's already all put together. The last one, we had to put it together, and that's true. That's sort of friendlier about this. But what is it about this one that makes it less friendly? It has an R, so there's 3 statements. So what does that mean about this truth table? It's going to be bigger. That's exactly right. Twice as big as the previous one, right? It's going to have 8 rows instead of just 4 rows. So it is nice that this one's already all put together for us. So we're already done with steps 1, 2, and 3 as this one starts the problem. But the truth table is pretty hard. It's big anyway. It's time consuming at the very least. So we're going to create a truth table with columns for P, Q, and R. Okay, do you remember what happens in column P when you have 3 statements? Excellent. In unison. Lovely. 4 truths. And then 4 falses. Very good. Do you remember what happens in column Q?
True, true, false, false.
It is. So they go kind of in pairs. True, true, false, false. True, true, false, false. And what about, yeah, and then R oscillates. Okay, so do you have to fill those in right now? No, I usually do, and then I finish all my column headers after this. Okay, so this is how I'll always start with 3 statements, the truths, and the falses, and it's not because this is the only right way, by the way. It's just a very sort of rhythmic way that we can make sure we get all the arrangements of truths and falses for every statement. We don't accidentally skip one or put one in there twice because we have this rigorous, detailed, always the same order kind of thing. All right, so looking inside of this long statement at the top, first of all, notice there's no negations. Do you notice that? Okay, so don't have to worry about any of that. There's several sets of parentheses, though, and we just move sort of from the inside out from left to right. So in the bracket on the left-hand side, there are 2 sets of parentheses, right? So we'll just do the first one first and the second one second. So the first column that we're going to write down, the new one, is the P implies Q. That's my first one here, and I'll call this column 1. And then the next set of parentheses is the Q implies R, and I'll call that column 2. So the individual sets of parentheses on the left-hand side are done. Okay. And then we join the 2 individual parentheses on the left-hand side with the symbol for and. So it will be a column header that's 1 and 2. And again, I'm going to relabel it 3. All of this on the left-hand side is now 3. Otherwise, I run out of space. At least up here. You probably won't in your paper, but I would up here. Okay, as I consider the left-hand side now being done, I'm going to look at the right-hand side. The right-hand side also has a parentheses piece that I need to have included in my table. So that's my next column header. It's P implies R. And might as well call it number 4. So on the right-hand side, that's 4. And then I'm ready to put it all together. What might my column header say to put it all together? Yeah. 3 implies 4. And we'll do highlighting as we go along like I did the last one. Okay, is everybody ready? So the first one we're going to do is P implies Q. And it is moving, this whole table is going to move from left to right very nicely, so that's friendly. All right, so these are a lot of implications. There's one and statement in here, but a lot of implications otherwise. So true implies true and true implies true. That's actually the first 2 rows. They're both true. The next 2 actually match as well. They say true implies false and true implies false. So when I have those 2, what do I get? Those are falses. And then the last 4 all start out false, which means the implication is true. Again, if you're wanting to remember the whys behind that, that's in section 3.3. Are we okay with that column? All right. The next one we're going to do is the column Q implies R. Okay, same thing as before, right? Still implications as well. So row 1 is true implies true. That is true. Row 2 is true implies false. That is false. Row 3 and 4 both start out false, which give me a true and a true. Yep. Row 5 is true implies true, so it's good, true. Row 6 is true implies false, which is false. Good. And then rows 7 and 8 both start out false, which give me true. Okay, what do you think? All good? Okay. Trying to get a hold of this last one. Make it go away. Here we go. All right. One I've called column 3. It says that I go back to columns 1 and 2, and I join them with an and. And when is an and statement true? When both statements are true. So on the first row I have true, true. So it's true. The second row is true, false. False. Row 3 is false, true. Row 4 is false, true. False. Remember, order doesn't matter on these in the slightest, just looking to see if they're both true. Row 5 is true, true. True. Row 6 is true, false. Row 7 and 8 are all trues. So we get 2 trues on those 2. All right. Moving right along, now we're going to column 4. It's P implies R. So here's P, and here's R. And again, we're moving from left to right, implication. Okay, not an and statement, now an implication. So row 1 is true implies true. True. Row 2 is true implies false. That's false. Row 3 is true implies true. And row 4 is true implies false. And then rows 5 through 8 all start out false, so they are true. Okay, ready for the last column? So the last column is an implication as well of 3 implies 4. All right, almost done. True implies true is? Good. The next 3 all start out false, so we get true. Row 5 is true implies true, which is true. Row 6 is false implies true. And then rows 7 and 8 are true implies true, which is true. So what do we notice about this one? It's valid because it's a tautology. So I don't have space down there at the bottom much, so we'll put it right here. This is a valid argument, simply by looking at that last column. Okay. So, Isabella, the test can't take forever because it can't ask you a bunch of them, right? Maybe it's true. I can't just give you a whole bunch of these. That won't work time-wise. Okay. So, number 3, what you'll notice is that we're going to do all 4 steps. Right? This word form looks like what happened back in section 3.5 with Euler diagrams, doesn't it? We're drawing circles and things like that. Euler diagrams can be used with these, and that's possible, but what you see actually in the structure of how they form their language is that these are generally given as if-then statements, and Euler diagrams are generally done with things like all, some, and none. That is something that you see a little bit different between them. They can be rewritten one to the other, but generally we use the all, some, and none kind of things with Euler diagrams, and we use if-thens with truth tables. So here's our statements. If I were a woman and you were my man, then I'd never stop loving you. I've stopped loving you. Therefore, I am not a woman, or you are not my man. Okay? So what we have to do first is we have to assign letters for the individual statements. And so remember, individual statements don't include any of the connecting pieces, like the ifs and the thens and the ands and the ors. None of that's part of those, okay? So we want to find the individual statement. So somebody find an individual single statement for me. What do you got, Isabella?
If I were a woman.
Yes, but without the word if. Okay, so I were a woman, and again, the verb tense is not important. You could say I were, I am, I would be. I don't care what letter, what phrasing of that verb's in there. So we're not going to worry about it later if it changes it to were and it changes it to am not, right? Like that's not important, okay? What's another statement that you see? You were my man. We'll call that one Q. There's one more statement.
Never stop loving you.
Yeah, I'd never stop loving you, and that will be statement R. Now we see them show up again in the next two sentences. So as we see them show up again, we'll use them. But let's do this sentence in symbolic form first. It says, if I were a woman and you were my man, how might those two pieces be joined together? Right. P and Q. I know there's an if in front of it. I haven't gotten to that yet. But the and part connects the P and the Q like this, right? But it says that that is the if part of something that follows. And what follows? I'd never stop loving you, which is R. So this is my first sentence in symbolic form. P and Q joined together implies R. What do you suppose my second sentence is going to say in terms of symbols? I've stopped loving you.
Negation R.
That is negation R. Wonderful. And then I have that therefore line. What is it there for? It's there to separate things, right? And I have my third sentence. My third sentence says, I am not a woman or you are not my man. What is that going to look like? Negation P, negation Q. What's going to go in between? The or V, yeah. So this is step 1 and step 2. Step 1 was where we actually identified the P, Q, and R. Step 2 is where we write all the symbols down with the appropriate arrows and ors and ands and all of that with the therefore line, all that stuff. Step 3 is to take this, like we did over here, and make a single if-then statement. So again, the way that we do that is we take the first two statements and we join them with the and connective. So we're going to write P and Q implies R and tilde R. And all of that joined together will be the premise or the antecedent of the part that comes after the therefore line. That's tilde Q or tilde P or tilde Q. Okay. Now we're going to do a truth table for this. This is the hardest truth table we've done. It has the 3 letters, like the last one, but it's also got some negations in there, right? It has and statements, or statements, and if-then statements. All of them are present. Right, this is like the ultimate truth table of everything we've done this unit. Okay? So I'm going to copy this to the next screen so that I can see it as we're creating our column headers. Okay, so just like on the last one, we need a column for P, a column for Q, and a column for R. So we'll start with that. And I won't belabor the point. You all know how to do the P, Q, and R, T's, and F's. We just did it a moment ago. So we've got 4 trues, 4 falses. And then we have our, looking a little bit tighter than I thought. Okay. Oscillating by 2s. And then every other one. Okay, cool. So looking from the left to the right, inside and moving out, the first thing that we see we need a column header for is what? P and Q, and I'll call it column 1. And then what am I supposed to do?
The 1
Mm-hmm.
implicates.
Sorry, I didn't write that right. I was too worried about my arrow. 1 implies R. Mm-hmm. Okay. And again, I will call that another column header. I'll call it 3. Why I chose 3? How about 2? Let's go in order. Oh my goodness. Here's 2. So we've done everything in the first implication. I've got an and statement, but I don't have a column header for what I'm trying to do the and statement with. So at this point, I need tilde R, right? So again, I don't usually put them in until I need them, often because it allows them to be in the right sort of left to right location when I'm doing if-thens, and I like to keep them that way if possible. So there's the tilde R. And then we'll take that column 2 with my tilde R column. And that's everything inside the bracket, I think. Yes? Yes. Okay, so we'll call that, now we'll do a 3. So this whole side of the arrow is 3. Now, if you look to the right-hand side, you see we have need of several things, right? A tilde P, a tilde Q, and an and statement. And you can see also I'm running out of space to put them all in, so I'm going to do my best. Tilde P, tilde Q. And then I have tilde P and tilde Q. Sorry, and or tilde Q. And the last one, we'll shrink it to get it in there in a second. The last one will be to take 3 and my new column that I just created, 4, and to do the arrow between. This is now 4. Okay, with enough space, so we can write it tight. So I have 3 implies 4. Okay, everybody good? It's messy, right? All right. We have P and Q, and it's an and statement. And statements are true when both are true. The first 2 are true trues. The second one, the third one is true false, so it's false. True false, so it's false. And then the last 4 all have false in the P column, so they're all 4 false. Then I have 1 implies R. So unfortunately, whoops, I lost my lines. Okay, well, it just wasn't want to do it that way. Put it back in. Oh, I know why I did that. All right, they're just going to have long lines. The next one is 1 implies R. So column 1 was right here. And here's column R. And we're going backwards, unfortunately. So 1 implies R. So the first row says true implies true. That's true. The next one is true implies false, which is false. The next two in the P and Q, or the number 1 column, are both starting out false, so they're trues. Actually, the rest of them, all of them are. Wow. Rows 5 through 8 are also all starting out false in the P and Q column, so they're trues. Then we're going to take take the column R, and we're going to do tilde R to it. So we're going to reverse the R column. So R was true, false, true, false. So now we're going to reverse that, making them false trues all the way down. And then this one's actually in order. So we're going to do column 2 and column R, tilde R. And it's an, oh, actually this is an and statement, so it doesn't matter what the order is. Oops, yeah. Column 2 and column R. And statements are true when both are true. So the first one's false, and the second one's false, and the third one's false, because there's at least one false among them. The fourth row is true, true, so that's true. The next one is true, false, so it's false. Row, what are we on? 6 is true, true, so it's true. Row 7 is true, false, so it's false. And row 8 is true, true, so it's true. The next two are tilde columns, so we will reverse the tilde. They're the columns for P and Q that we already had. Tilde P was 4 true, 4 false, so now I need 4 false. And then 4 true. Row Q, tilde Q, will be false, false, true, true, false, false, true, true. And now I'm going to join these with or. When is an or statement true? When at least one of them is true, right? So on row 1, I have false, false, so that's false. Same for row 2. Row 3 is false, true, and row 4 is false, true, so those are both true. Rows 5 and 6 are true, false, so those are both true. And rows 7, 8 are both trues, so they're trues as well. We're almost done. Our last one. Our last one is to take row 3, column 3, and column 4, and to do an implication. Okay, so if it starts out false, it's automatically true, right, for an implication. So the first 3 are true, because they start out false. Row 4 is true, implies true, which is true. Row 5 starts out false, so it's true. And row 6 is true, implies true, so it's true. Row 7 is false, true, so it's true. And the last one, true, true, is true. So
if then statement, as long as it ends with a true statement, it's automatically going to be true?
No, well, that's a true what you just said is true, but it isn't just that it ends in a true statement, it's that it starts either with, because you could end in a false statement and it'd also be true. Like a false implies false is true.
Oh.
So if it starts out true and ends true, or if it starts out false, that's when an implication is true. So this one's a tautology, yes, which makes the statement valid. This is a valid statement. Okay, I think you'll like the next part. You might be looking at this thing. There's only 5 minutes left. Do we have time? And the answer is yes. Okay?
I'm kind of scared about how you said that.
It is. We've got plenty of time. You just watch. So there are actually 6 different forms of arguments. 4 of them are valid and 2 of them are invalid. The valid forms are listed in this box. One of them is P implies Q and P, which makes it Q. So that's valid. That's called modus ponens. The second one, P implies Q and tilde Q gives me tilde P. That's modus tollens. Those are valid. Notice that statement for the next one, disjunctive syllogism, is the only one that's not a conditional. It's an or statement. P or Q, right? If P or Q is true, and you have tilde P, which means P is not true, then it must be that Q is true. That's disjunctive syllogism. Reasoning by transitivity, we did this. Example number 2 was actually us proving reasoning by transitivity. If P implies Q and Q implies R, then P implies R. Okay, so it works something like this. If it is a strawberry, then it is red. If it is red, then I eat it. Therefore, if it is a strawberry, then I eat it. That's what that says, right? It's one step to the next. It's almost like an equality, like A equals B equals C kind of thing. There are 2 invalid argument forms, also called fallacies. P implies Q, therefore Q. And Q, therefore P. That's fallacy of the converse. This is something like it would say, if it is snowing, then we don't have school. And then Q says, we don't have school. It would not be appropriate to then assume that it is snowing, because it might just be Saturday. Right? Yeah. And the same thing happens on the fallacy of the inverse. P implies Q, and not P happens, right? Tilde P happens. Does not necessarily mean that tilde Q will then follow. So what we're going to be doing on the last 2 examples is actually taking sentence structures and writing them in symbols and then deciding, like matching, which one does it match? That's it. Okay, and since you're not being asked to memorize these, you're just really looking back and seeing which one does it match. So there are statements much like my if I were a woman and you were my man stuff that we're going to identify. So the first one is she buys another pair of shoes. And her second statement is her closet will overflow. So the first one is P implies Q. What's our second statement? Her closet will overflow. What is it? So it's just Q, right? Yes?
Yes.
Yes. So what goes underneath it? She buys another pair of shoes would be P. Okay, so you're creating the structure, and then you're coming over here and you're saying, which one of these is it? And which one is it? Be really careful. It's actually fallacy of the converse. They look very similar. Modus ponens and modus tollens have similarities to the other ones, so be careful. It's actually invalid by fallacy of the converse. Let's try one more and we'll be done. If Kerry Woods pitches, the Cubs win. There's the Kerry Woods pitches. Here's the Cubs win. So the first one, much like the last one, is P implies Q. What's our next statement? The Cubs don't win, so that would be tilde which, P or Q?
P, tilde P.
Q.
What? Oh, the Cubs.
The Cubs is the Q part. Okay.
Okay, why don't we use P and Q? Why don't we use, like, A and X?
I don't know why they use P's and Q's. But I will say it's common between, like, curriculums that I've used, so it must just be the standard convention. Okay, real quick. Kerry Woods does not pitch, which would be tilde P. Which one does it match?
Modus tollens.
Modus tollens. So it is valid by modus tollens. Okay, so these are multiple choice kind of things you're going to see inside of my math lab. All right, so homework and quiz are due Sunday night. You should be able to finish those at this point. And we will not meet on Friday because we've finished 3.6. On Monday, we will have our review in class with a test on Wednesday. Have a great week, guys.